Level 14, lecture number 3. Okay, so in this module, we will be discussing work, energy, and power. Okay, so work. Work is a scalar quantity and it is defined as the force applied to an object causing a displacement. So, the unit of work is joule, which is equivalent to Newton meter. So, pag sinabi nating work, since sinabi dito na scalar quantity siya, ibig sabihin wala tayong kinoconsider na direction. Now, yung work kasi sa English, parang isipin mo basta kailangan mag-exert ka ng force, meron kang work. Kaya lang sa physics, meron siyang different definition. Kailangan yung force na in-apply mo sa isang object, kailangan mag-cause siya ng displacement. Or in short, kapag nag-apply ka ng force sa isang object, dapat gumalaw yung object or merong movement dun sa object. So, yung formula ng work is given as work is equal to Fd cosine theta, wherein F is the force, D is the displacement, or in other terms also we use distance kasi kung yung displacement is hindi naman nagbago ng direction, therefore equal din siya sa value ng distance. And then this is equal, and then you will multiply this with the cosine of the angle theta. Now, yung angle theta, remember that this is the angle between the force and the displacement. Okay, so let's look at the different examples of work kasi may different cases siya. So, for example, a force is acting to the east. Okay? It is acting to the east which causes a displacement also to the east. Okay. So, if you notice dito, parehas ng direction yung displacement and yung force. Kaya sinasabi natin that the angle between F and D is 0. Okay, so kung babalikin natin yung equation ng work is equal to Fd cosine theta and papalitan natin yung theta ng 0 degree, okay, so magiging ganito siya. Fd times cosine 0. Now, note that cosine 0 degree is equal to 1. Okay, so pag ginamit niyo sa calculator, o chinig niyo sa calculator, ang value ng cosine 0 is 1. So, ibig sabihin, itong term na to, makakancel siya kasi this is just equal to 1. Kaya, pag sinimplify natin siya, magiging work is equal to Fd. Or, ito yung tinatawag natin na meron tayong positive work done. Kasi positive yung value ng work. Okay, so, kailan nagkakaroon ng positive work? Okay, it will happen if the force and displacement are acting in the same direction. Okay, so, dun tayo meron positive work. Basta parehas ang direction ng force and displacement. Okay, for example, meron kang table, tapos itinulak mo siya papunta sa right. Okay, so kung mag-apply ka ng force going to the right, yung table mag-move din also to the right direction. Okay, kaya sinasabi natin na in that case, meron tayong positive work done on the table. So, yung applied force mo na ginawa mo dun sa table, you have done positive work on the table. Okay, so examples of positive work. So, yan nga. So, kapag tinulak mo ang table, kung saan ang direction ng applied force, yun din ang direction ng movement ng table. Or, for example, kapag tinaas mo yung baso mo na nakapatong sa table, yung applied force mo is pataas. So, ganun din yung direction ng baso. Okay, let's look into another case of work. So, this time, you have a force that is acting to the east. Okay? But the displacement is to the west. Okay, so magkaiba sila ng direction. So in this case, pwede natin sabihin na yung angle between the force and the displacement is equal to 180 degrees. So kung babalikan natin yung formula ng work katulad ng ginawa natin kanina, so isa-substitute natin yung angle theta with 180 degrees. So now you have Fd cosine theta. But we know na pag kinompute mo yun sa calculator, cosine of 180 degrees is negative 1. Kaya pag sinubstitute mo dito, magiging negative 1 to. So therefore, pag sinimplify mo to, magiging work is equal to negative Fd. Or we also call this as negative work done. Okay? So, tanong, kailan nagiging negative ang work? So, based dito sa nakita nyong illustration, we can say that if the force and displacement are acting in opposite directions, the work done is negative. Okay, so ganun lang kasimple. Basta opposite directions ang force and displacement, ang work natin is always negative. So let's look into the other examples of work, negative work. So, for example, tinulak natin yung table. So, yung friction ay may negative work sa table. Bakit? Kasi, ang direction ng friction is always opposite to the direction of the movement of the object. So, therefore, sa case na to, kanina, yung applied force mo does positive work on the table. So, this time naman, yung friction naman does negative work on the table. Dahil nga, ang direction ng friction force is acting to the opposite direction of the table. Negative work din yung karaniwang, sinasabi natin na ang negative work ay karaniwang dahil sa friction. Kasi ang friction ay laging opposite sa motion ng ating object. Let's look into another example of work. Okay, so this time, you have a force that is acting to the north, but the displacement is to the west. Okay, so as you can see here, the angle between the force and the displacement is equal to 90 degrees. Okay, so if we will substitute this in the equation, yung FD cosine theta, so yung theta palitan natin ng 90 degrees, we know that the value of cosine 90 is equal to 0. So you can go and check that in your calculator. So pag sinubstitute natin siya, nangyayari, since any number multiplied to 0 is still equal to 0. Kaya ito magiging work done is equal to 0. So 0 work done. Okay, so kailan ito nangyayari? So if the force and the displacement are perpendicular to each other, the work done is 0. So ito yung sinasabi ko kanina na hindi porket nag-apply ka ng force, ibig sabihin meron kang work. Actually, nakadepende yun kung yung force mo is ano yung direction niya, ano yung angle niya with respect to the displacement. So, just like in this case, basta perpendicular ang direction ng force sa displacement, ang work done natin is equal to 0. Okay, let's look into another example ng work na meron tayong 0 work done. Okay. So, kapag may karga kang sako ng bigas at naglalakad ka, may horizontal displacement ka. Pero 0 ang work done dahil ang direction ng applied force mo sa sako ay pataas. Okay, this is along the vertical. So, therefore, perpendicular ang direction ng applied force sa displacement. Actually, this applies to any object na halimbawa, dala-dala natin siya. So, remember na kapag dala natin ng isang bagay, nag-exert tayo dito ng applied force na opposite sa direction ng weight ng object para ma-support natin yung weight ng object. So, dahil pataas yung applied force na yun, pero kapag naglalakad tayo, horizontal yung ating displacement. Kaya therefore, yung ating force and yung displacement natin is perpendicular to each other. Kaya in this case, kahit na sabihin natin na meron tayong applied force on the object, we do not apply work and there is no work on the object. Okay, so pag i-apply natin ng work sa industry. So we have here the work done in engines. So the work done in one cycle of 2-stroke and 4-stroke engines is given by this equation. Work is equal to the mean effective pressure, which is P sub M, times AL. So the area of the piston and the length of the piston. So this is actually also equal to FD. Actually, in this case, yung F is equal to P times L, which is something that you will learn later on pag pinag-usapan na natin yung pressure. And then the L here represents the displacement. Okay, bakit? Kasi di ba ang movement ng piston is only in up and down motion. So since up and down motion lang naman yun, ibig sabihin, so that will be equivalent to the length of the piston. Okay, let's have this example. You have a horse that is towing a barge with a rope that makes an angle of 20 degrees with the canal. If the horse exerts a force of 400 newtons, how much work does it do in moving the barge 1 kilometer? Okay, so to solve this problem, kailangan muna natin isulat lahat ng given quantities and unknown values. So, first we start with an angle of 20 degrees based on the problem, it says here. And then you have a force of 400 newtons. You have a distance or displacement of 1 kilometer. So, we're looking for the work done. Okay, so kailangan muna natin i-convert sa meter ang displacement dahil ang unit ng work na joule ay equivalent sa Newton meter. So, ang gagamitin natin instead na 1 kilometer is 1,000 meters. So, pag sinusolve pag sinove na natin yung work, so that's equal to, work is equal to FD cosine theta. So, substitute lang natin. So, you have 400 newtons times 1,000 meters times cosine 20. So, therefore, the work done by the horse in towing the barge is 3.76 times 10 to the 5th joules. Example number 2. A tugboat exerts a constant force of 5.80 times 10 to the 3rd newtons on a ship moving at a constant speed through a harbor. How much work does this tugboat do on the ship if it moves a distance of 3 kilometers? Okay, so para ma-solve natin yung problem, again, kailangan muna natin isulat lahat ng given and unknown quantities. So, we'll start with 0 degree, which is the angle. And then you have the force, which is 5.8 times 10 to the 3rd newtons. Then you have a displacement or distance of 3 kilometers. So, convert na natin ito agad sa meter. So, times 1,000 lang. So, you have 3,000 meters. And we're looking for the work. Now, you may be wondering bakit 0 yung angle theta. Kasi, same direction ang force and displacement. Kaya 0 ang angle. Okay? So, wag lang tayong malito doon. Kasi, remember na kapag nag-exert ng force yung tugboat dun sa ship, kung ano yung force na exert ng tugboat to the ship, ganun din naman yung magiging direction ng displacement ng ship. Okay, so kung gagamitin na natin yung work formula, so you have work is FD cosine theta. So, multiply 5.80 times 10 to the 3rd newtons times 3,000 meters times cosine 0. So, since alam natin na cosine 0 is just equal to 1, so therefore, the work done by the tugboat on the ship is 1.74 times 10 to the 7th joules. Okay, so another concept na inaaral natin na related sa work is the energy. Now, the energy is defined as the capacity of a body to do work by virtue of the position or motion of the body. So, ang unit ng energy is also equivalent sa unit ng work. Bakit? Kasi di ba nga, dinefine natin yung energy na capacity of a body to do work. Kaya related sila. So, in a way, you can say na para magkaroon ka ng work done, kailangan mo ng energy. So, you have different forms of energy. So, for example, dito, you get chemical energy from fuel. Then, you have here solar energy, which is coming from the sun's rays. And then, you also have here wind energy. So, let's look into the different forms of energy. So, you have basically two forms. You have potential and kinetic energy. So, when we say potential energy, this is the energy something has by virtue of its position. So, may ginalaman siya sa position niya. So, that's why we have here P is equal to mgh. So, m is your mass, and then g is your acceleration due to gravity, which is 9.8 meters per second squared, and yung height. Okay, so, for example, as you can see here, yung potential energy natin is nakadepende siya basically sa mass at saka sa height. So, ibig sabihin, pag mas mataas ang mass mo, mas mataas yung potential energy mo. And kapag mas mataas ang height mo, mas mataas din ang potential energy. Now, the other form of energy is the kinetic energy. So, the kinetic energy is possessed by objects in motion. So, kung i-contrast natin yung dalawa, yung potential energy, this is the energy at rest. Ibig sabihin, hindi gumagalaw yung object. Nasa isang position lang siya. Ang kinetic energy, dito nangyayari lang to kapag yung object meron na siyang movement. So, Ke is equal to 1/2 mv squared. So, again, m is for the mass, and then v here is for your speed. So, as you can see, itong kinetic energy, dependent siya sa both mass and the speed. Pero, dito sa dalawang to, mas malaki yung effect ng speed kaysa dun sa kinetic energy. For example, kapag dinouble mo yung value ng mass, double din yung value ng kinetic energy. Pero kapag dinouble mo yung value ng speed, ano ba yung 2 squared? So, it's equal to 4. Kaya yung value ng kinetic energy mo, magiging 4 times the original value. Okay, so you have here, PE is equal to mgh. So, let's look at this study, ano? So, in this illustration, we can say that, Okay? The PE is directly proportional to the height. So, ang potential energy ay pinakamalaki kapag mataas ang height ng object. So, kung mataas ang position ng object, mas mataas din ang PE. So, let's say meron kang swing dito. Okay, so yung bata na nagsiswing, so pinaka-highest ang potential energy niya doon sa points na pinakamataas siya. So in this case, ito yon. Nandito siya sa pinakamataas na point. So, pinakamataas ang potential energy niya. Pagdating dito sa gitna, okay, so halos equilibrium position, we can say na ito yung may pinakamaliit na value ng potential energy. Why? Kasi ito yung may pinakamaliit na height niya from the reference point. So in this case, it's the ground. Now, for kinetic energy, you have 1/2 mv squared. So, katulad nga nabanggit ko kanina, the kinetic energy is directly proportional to the square of the speed. So, mas mabilis ang speed, mas mataas ang kinetic energy. So, for example, kapag double ang speed, ang kinetic energy ay magiging 4 times or magiging quadruple. Okay, let's try to guess. Paano pag in-increase mo ang speed ng 3 times. So, mangyayari, yung kinetic energy mo, magiging 9 times greater. Eh, what about kung let's say, speed mo, ni-reduce mo sa 1/2. So, ano ba yung square ng 1/2? Ang square ng 1/2 is 1/4. Kaya, mangyayari, yung kinetic energy mo, magde-decrease by 1/4 its original value. Now, let's look into the law of conservation of energy. So, ang sabi dito, energy is neither created nor destroyed. So, it is simply transformed from one form from one form to another. So, ang energy hindi talaga siya naggagawa, hindi siya made, but instead, parang recycled lang siya. Now, the law of conservation of energy states na yung total mechanical energy or TME, this is the value na nakukuha natin kapag ina-add natin yung kinetic at yung potential energy. At yung value na to ay constant. Okay? So, ibig sabihin, dito sa animation natin sa baba, as you can see, meron tayong ditong 3 graphs. Okay? At bawat isa dito gumagalaw. So, maliban lang dito sa TME or the total mechanical energy. Bakit hindi ito gumagalaw? Kasi ito nga ay constant. So, kapag in-add mo ang kinetic energy at potential energy, parati lang siyang equal to the value of the total mechanical energy. So, in this case, let's say, ma-observe nyo itong cart, okay, pinakamataas ang value ng kanyang potential energy kapag nandito siya sa highest point. Okay? Tapos, habang pababa siya ng pababa, okay, bumababa rin yung value ng ating potential energy. Now, yung kinetic energy naman, if you notice, kapag nandito yung cart sa pinakataas, okay, nagiging 0 ang value ng kinetic energy kasi wala pa nga siyang movement. Ayan. Tapos, habang bumababa siya, tumataas ang value ng kinetic energy kasi nagkakaroon na ng motion ng iyong cart. And actually, habang pababa yung cart mo, mas lalo siyang pabilis. Kaya tumataas yung value ng ating kinetic energy. So, we can say na itong value ng potential energy mo sa taas, okay, pinaka-maximum siya dito sa taas, okay, pero, okay, pag hinintay natin yung cart na ma-reach niya tong point na to, kung mapapansin nyo, yung kinetic energy naman niya ang maximum. And then, yung potential energy niya, magiging 0 na. Bakit? Kasi lahat ng potential energy, na-convert na siya into kinetic energy. So, as you can see, ito na yung cart, papalapit na siya rito. There. Maximum ang kinetic energy, pero 0 ang potential energy. Okay, so let's have this example. So, a large cruise ship of mass 6.50 times 10 to the 7 kilograms has a speed of 12 meters per second. So, let's calculate the following. So, you have the kinetic energy of the ship, the work required to stop it, and the force required to stop it if it has to be stopped over a distance of 2.5 kilometers. Okay, so for example here, again, kailangan na naman natin isulat yung ating given and unknown quantities. So, mag-start tayo sa mass. You have 6.50 times 10 to the 7 kilograms. And you have a speed of 12 meters per second. So, we need to calculate the kinetic energy, the work done, and the force. This is over a distance of 2.5 kilometers or that's equivalent to 2,500 meters. So, solve muna natin yung KE. So, the kinetic energy is 1 half mv squared. So, substituting these values, so we have kinetic energy is 1 half times 6.50 times 10 to the 7 kilograms times 12 meters per second. And then you will get the square of this. So, you have the value of 4.68 times 10 to the 9th joules. Okay, so ito na yung value ng kinetic energy ng ship. Now, remember kanina, di ba na-discuss natin na yung energy is the capacity to do work. So, given that scenario, okay, alam na ngayon natin na ang kinetic energy ay equal lang dun sa work na kailangan natin para mapahinto yung ship. Kaya therefore, the work required to stop the ship is also 4.68 times 10 to the 9th joules. So, this time, para ma-compute ang force, gamitin na equation ng work. So, dahil opposite ang direction ng force o displacement, ang angle natin is 180. Okay, so this time, let's have power. Okay, so power is the rate at which work is done. So, the unit is watt or joule per second. So, 1 horsepower is equivalent to 746 watts. So, we have the formula na power is equal to work over time. So, you have FB cosine theta. So, minsan ginagamit din natin ito kapag given naman tayo ng speed. So, again, so P is for power, W is for work done, T is for the time. You have F for the force, V is the speed, and then cosine theta. So, the theta is for the angle between the force and the velocity. Okay, so for example, the engines of RMS Queen Mary could deliver 174 megawatts to propel the massive ship. How long does it take for the 4 engines to do 7.31 times 10 to the 10th joules of work on the ship? So, we note that the conversion factor is 1 megawatt is equivalent to 1 times 10 to the 6 watts. Okay, so again, just like in solving any other problem, susulit muna natin yung given and unknown quantities. So, you have the power, which is 174 megawatts. You have the power work, which is 7.31 times 10 to the 10th joules. So, we're looking for the time. Okay, kasi ang tanong dito is how long does it take? Okay, so kailangan muna natin convert ang megawatt into watt. So, multiply lang natin yung 174 megawatts sa 1 times 10 to the 6 watts. So, in this case, makakancel natin yung megawatt. So, you have a power of 1.74 times 10 to the 8 watts. So, solve na natin ang time gamit ang formula ng power. So, since power is equal to work over time, kailangan lang natin itong i-translate. So, mangyayari nito, pagpapalitin lang natin yung position ng P at saka T. That's the easiest way to do that. So, you have here, T is equal to work over power. So, that's 7.31 times 10 to the 10th joules divided by 1.74 times 10 to the 8 watts. So, you have 420 seconds. So, therefore, it takes 420 seconds for the ship to stop.